Good day, my name is Matthew Eades, and I'm going to be presenting to you my plant incubator, which I designed for my electronical project for this term at New Cloud. This is the plant incubator. It creates the perfect environment by controlling the lighting, humidity, temperature, as well as wind. It creates the ideal environment for plant cloning, plant acclimation, seedlings, and seed germination. The problem statement: to design and build an affordable and efficient plant incubator that regulates the environment for either clones, seeds, or seedlings. The plant incubator will maintain the chosen environment settings to produce the best growing conditions. The plant incubator is also able to acclimate your clones or seedlings from one environment to the other, for example, indoor to outdoor, to provide less stress on the plant. The plant incubator is suitable for home growers that require regulated environments, as well as growers that are passionate about breeding and genetics. So this is the plant incubator. How it works: you set your temperature and humidity values to your chosen values. You set the lighting schedule. The device will then regulate the temperature and humidity based on the set values. Your light will also turn on and off based on your set times. You then leave it and let your seeds, seedlings, or clones grow. For research, I looked into many different smart farming projects that were out on the Arduino website, and just looking at what projects I could potentially take a lot of inspiration from. And I really like this design in the middle here of a little plant grower that tells you the temperature and humidity. But this project doesn't do any regulation. It just simply grows and tells you what the temperature and humidity was. So I thought I would expand and take this project a bit further, creating my plant incubator. I also did lots of research into coding and electronics, trying to figure out the different components I'll use for my project, as well as understanding the programming of each component, just to build a greater understanding. Also did some research into the different competition that was on the market, looking at different products that were out there, and there's not much that really does what mine does. You get the Aurora Plus, which is a seed germinator, which is a project I actually designed last. The Pico herb grower for your kitchen planter, heat mat for like seedlings and seeds, just a normal humidity dome, and then the vertical connect, which is also a little herb grower for your counter that just provides light. So I started looking at doing different sketches of what the product could maybe look like with all the included components, and just trying to figure out how the whole thing would work. And I did some very rough sketches, and then moved towards doing a very basic 3D model on SolidWorks, where I could just try to figure out the shape and make sure everything was going to fit and work together. From there, I slowly added each little detail and components to come to the final model. This is where I spent quite a bit of time just trying to get a perfect product to manufacture. This is a little video of an explosion view of the product. These are all the electronics I use for my project. I'm going to take it to all of them, but the main one here, the floating humidifier, which I use to create the humidity, as well as the cement heat resistor, which I use to heat up the product. And then you can just see the lights and the screens and the fans. This is the wiring diagrams that I worked off. I thought it was very important to try to break down the project into very neat wiring diagrams, just try to understand what each component did and where each wire went. So I did some PC board designs up here, as well as just some other designs just to help me keep in track and order with the wiring. And then in terms of the coding, this is where I spent quite a lot of time working on the code and trying to get the program to run efficiently and smoothly. So how I worked it is I worked each individual component separately and try to figure out how each part worked. And then from there, took each part and slowly added them together to come up with the final code. And the final code, now you can set the real-time clock it reads the temperature and humidity values. The atomizer reacts to the low humidity. The heater reacts to the low temperature. The fan turns on with excessive heat and humidity, and the real-time clock alarms for the LED to turn on and off. This is the parts list that I put together after creating the project. As you can see, I've divided it between the electronical parts and then all the parts that I used to build it. I'm not going to take you through all the parts, but here you can just see how many components and features have been put together to create this plant incubator. And the bill of materials. So the total cost of all the materials for this project was 1,640 Rand. I spent a total of 356 Rand on materials. Thanks to New Cloud, I could use lots of the materials found around the class to build the project. And I'm very happy with where the product sits in terms of its price for now. I think it's got good potential for the market. In terms of products and testing, I haven't done too much product testing yet. And I first need to resolve the waterproofing to make sure none of the electronics burn out. Also need to look at increasing the size of the floating humidity tank to be able to hold more water. And then I'd also like to look at designing a phone app to control all the settings instead of having to open up the Arduino interface, as well as look at adding acclimation process into the code. And this would be helpful having the app. And also look at ways of making the device a little more accurate. Sometimes the humidity and heat can overshoot. For time management, I rate myself a 7 out of 10 for the time management. I think I managed my time fairly well for this project. Missed 2 weeks due to having COVID, but luckily I was able to try catch up as quick as possible to get back on track. But yeah, I think the most important thing of this was just trying to keep to the 10-week schedule and making sure everything is up to date. The skills I learned over the course of this term. Yeah, so the most important thing is just try to keep up to date. As I said, it's been good to be a little bit prepared and stay ahead in case anything happens, because anything can happen at any time. So just sticking up to date is really important. I've also learned a lot about the Arduino interface, as well as feeling a lot more comfortable with the programming of it. I also learned a lot about the understanding of electronics and how all the different components work. And it was cool to finally have a working electronic project. And also learned a bit more about the manufacturing processes using 3D printer and the laser cutter. My acknowledgements. I want to thank Nick for helping me understand the electronics a bit better, as well as helping me troubleshoot any issues I had faced along the way with the project and the course. I want to thank Richard for helping me with the 3D printers and the laser cutters, just showing me around each machine and getting me a great understanding of how they work. Also want to thank JC for all the help and PPD to get great to understand myself. For conclusion, I think the first prototype of the plant incubator was a great success. The plant incubator is now in working condition with all the electronic components working together. The incubator successfully regulates the temperature and humidity, as well as controls the light cycles. I think the plant incubator has the potential to go to the next level once the waterproofing and user-friendly interface is resolved. It is now ready for its first seeds to be planted and tested. For the professional ethics, this project can help any home grower or even big-scale farmer germinate difficult seeds, grow tricky seedlings, and clone sensitive plants. It can potentially be scaled up for larger operations. This project has the potential for you to save money on seeds, as the germination rate will be higher. This project will also be easy to understand and easy to use, so it will be suited for all. This is the plant incubator. Thank you very much for listening.